Math 3, Unit 11, Section 1. Today we're talking about the WhatPower function. So here's the definition. Based on the subnumber, so the subnumber is like the number down here, state the power needed in order to get the value that's in the parentheses. So WhatPower, base 5 of 25, is stating what power would you raise 5 to in order to get the value of 25. So WhatPower 525, the answer is 2, because 5 to the second power equals 25. So for the next examples, we're going to do the same thing. Again, here it's saying what power of 2 to what power will give you the answer of 16. And so 2 to the fourth power is 16. So what power base 2 of 16 is 4? 3 to what power equals 81? 3 to the fourth power equals 81. So my answer here is also 4. Okay, example 3. 10 to what power equals, and then this is 100,000. So if you count here, there's 1, 2, 3, 4, 5 zeros. And so 10 to the x equals 10 to the fifth. So what power is 5? 10 to the fifth power gives us the 100,000. On the next one, 3 to what power gives you the answer of root 3. So in order to get this answer, root 3, we need to figure out what root 3 would be as an exponent. And here, 3 to the first power is in here, and this is a square root. And so in order to change this to exponential form, this would be 3 to the 1/2. Whatever the exponent is, that goes on the top, and the root number goes on the bottom. So 3 to the 1/2 power gives you the root 3. 3 to the 1/2 gives you 3 to the 1/2. So 1/2 is the answer for example 4. Or sorry, oh, my numbering's off, sorry. Okay, so on the next example 4, it's saying 18 to what power gives you the answer of 1? Well, we know the only way to get the answer of 1 is by having an exponent of 0. So 18 to the 0 power gives you 1. So the answer is 0. Okay, example 5. 25 to what power gives you the answer of 5? So on this one, if you think, there's a couple ways of solving it, but in order to get a 5 from 25, we would have to take the square root of 25, because we know that the square root of 25 does equal 5. And so in terms of exponents or powers, this would have to be 1/2. Just like here, 3 to the 1/2 made root 3. 25 to the 1/2 would make a square root of 25, which then does equal 5. So my answer here is 1/2. Another way that you could think about this, and later on in the unit we'll get more into it, but if you were to get a like base, so if we were to change 25 to be the same base as 5, so we know 25 is actually 5 to the second power. On this problem here, we already have an x in the exponent, and so powers to powers you multiply, so I'd write this as a 2x. So all I did was change 25 to be 5 squared, and then I kept the x up there, equals 5 to the first power. Well, if these numbers are the same, that means the exponents would also be equal. And so we would go 2x equals 1 and divide by 2 to both sides in order to get the answer of 1/2. So that's another way of thinking through the process. But for the most part, we're hoping that you're going to be able to think through this as 25 to what power gives me 5. Well, 25 to the 1/2 power will give me the answer of 5. Example 7, 1/3 to what power gives me the answer of 1 over 27? So here, and it's really 1/3 is in parentheses, there's nothing I do to the 1. I can take 1 to any power and get 1. But what do I take 3 to in order to get 27? And so that's going to be 3 to the third power. So what power base 1/3 third will give me 1 over 27. Well, it's 3. 1 to the third power gives me 1. 3 to the third power gives me 27. Example 8. 2 to what power gives me the answer of 1 over 32. So we know that 2 to the 5th power gives me 32, but this 32 is in the denominator. And so in order to make it switch sides, it would need to be a negative 5. So 2 to the negative 5th power will give me the answer of 1 over 32. Example 9, 0 to what power will give me the answer of 5? Well, doesn't matter what power I put here, I'll always get 0. And so for this one, there is no solution. Example 10, what power base 1 will give me the answer of 9? So 1 to what power equals 9? It doesn't matter what number I put here, I'm always going to get 1, so this is no solution. Here we have negative 2 to what power equals 32. And whatever number, the number I need to put here in order to get to 32 would be 5. But negative 2 to the 5th power is actually negative 32, and so it doesn't work. This one also will be no solution. And example 12, 4 to what power equals 0? If I put 0 here, I get 1. If I put a negative number here, I get a fraction. So there's no value I can put in the exponent here that will give me the answer of 0. So this also is no solution. So the question is, what is different about examples 9 through 12? Well, first of all, we can see that those are all no solutions where all the other problems did have solutions. And can we make generalizations? So first of all, what's different? No solution. So generalizations about those 4, it looks as though you cannot have a what power for 0, 1, and negative 2. Also, 0 cannot be an answer in the parentheses. Because when we're doing this, we're always saying this little base here, this base to what power gives me this answer. So the answer part, the part that's in the parentheses, can never be 0. It won't work. All right.